Good evening, everyone. Welcome back to our last day of our program. So we have left out with the only topic. It is pandas. Okay. So far, I think we have a great session so far, right? So we'll quickly recap what we have covered in the last 9 days, guys. We started understanding what is Python, right? We initially understood the concepts of Python, right? We understood the history of Python, then the key features of Python. Later on, we understood the core concepts like variables, followed by data types, operators. Then, next to operators, we understood flow control statements. Under flow control statements, we understood conditional statements. Then, next to conditional statements, we understood looping statements. And next to looping statements, we have also understood control statements. No, in order to control the loops, there are control statements. We understood them as part of flow control statements. And post understanding flow control statements, we understood very important concept. It is functions. Right. So we, as part of functions, we have also understood lambda functions, special functions in Python. And in the last sessions, we understood the concept of NumPy module. We have understood a very important topic as part of this particular program. It is NumPy. Okay. So even in the last session, we have understood the concepts related to the NumPy. What is the purpose of NumPy? Okay. How vector calculations are possible using NumPy module. Okay. Then why it is fast. So if you have missed any of these sessions, just go back and have a look on the particular session, guys, because these are the core concepts, very important topics with respect to our programming language Python. And in today's session, we are going to learn, we're going to understand the left out topic. It is Pandas library. It is Pandas library. Okay, so we'll understand what is the purpose of Pandas. Okay, how to install Pandas. Then post understanding the purpose and the importance of Pandas, we'll also talk about the data structures that are available in Pandas, like series, data frame. How should we go and create a series object? Okay, first of all, what is series? What is data frame? So let us understand all the data structures that are available in Pandas. Then we'll also do hands-on with respect to these data structures. And we have, group by, how the data gets grouped by using the group by function that is available in Pandas. So we'll be using the group by function as well. Okay, so I'll just revise all these topics. We are going to learn all the new topics related to Pandas. So that will be the agenda for the day. So let us understand the purpose of the Pandas, followed by the setup of Pandas module. Okay, how should we install Pandas? How should we import Pandas? Let us complete the setup. And next to that, I'll talk about the data structures in Pandas, like series and data frame. Two important data structures, and continuously we will be working on series and data frame, especially data frames, guys. Okay, so let's start our show. Okay, so just maintain the same focus. Today is our last day, right? So let us maintain the same focus and complete this topic of Pandas. Right. So what is the purpose of Pandas? Let us get introduced to Pandas. Pandas is a Python library. It is an open source Python library which provides high performance. It gives you high performance with respect to the data. Okay. When you are especially working on the data, your performance will be very high. And the reason why we use Pandas is for data manipulation guys. Whenever you want to manipulate the data, you go and use Pandas. We'll go and use Pandas library. And using Pandas, we also perform analysis. So that is the reason behind Pandas. Right? So this word Pandas was actually derived from panel data. If you observe, PAN represents panel and DA in Pandas represents data. So from panel data, the word Pandas was derived. But who developed Pandas? It is Wes MC Kinney. Okay. So this person have developed Pandas in the year 2008. In 2008, it was being developed. And Pandas was officially developed in C and Python languages. In both C and Python languages, Pandas got developed. So if you go to the traditional Python, in Python programming, there is no particular library for performing data analysis. No. But when they have introduced this library called Pandas, we were able to perform the analysis on the data. We were able to perform the analysis. And using Pandas, we can use Pandas for wide range of fields, for finance services, statistics, retail marketing. So whatever might be the sector, if you have data and if you want to manipulate it, or if you want to perform analysis on it, you can go and use Pandas. We can go and use Pandas. Right? So this is a brief introduction about Pandas, guys. Now let us complete the setup as well. Let us complete the setup. So how should we install Pandas? Because earlier, if you remember, how did we install NumPy? How did we install NumPy? We have a command. There is a syntax for installing the packages. What is it? It is pip install package name or module name. Okay. Either it might be a module, package, okay. Whatever it might be, the command will be same, guys. Pip install module name. So I'll just use the same command and I'll install Pandas. Why should we install Pandas? Because this is not available in Python. Okay, in the traditional Python, you'll not find Pandas. You have to install this package first of all. When you install it, whatever the functions, whatever the classes, whatever the variables are available in Pandas, you can start using them. You can use all of these together. Okay, so installing is mandatory. Post installing, we should also import it. Only if you import the package or the module, you can use whatever things that are present in it. Right? Yes. Let me talk about the key features of Pandas. So Pandas, as we have discussed, it will be very fast. Okay, the execution will be very fast and efficient. Okay, so this helps us to create a data structure called data frame. What is a data frame? We'll understand. Okay, so we'll have data frames which allows us to customize our indexing. The index that we come up with can be customized. I hope you are aware of index. Yes, from last 9 days we are discussing about the topic of index. Right? So this index can be customized, and it also helps us to load the data in memory. Okay, so the data objects can be, loaded within the memory, like series objects, data frame objects, or panel objects. Okay, what is series, what is data frame, we'll understand. As we go on, you'll understand each and every terminology. Then we can also perform slicing and indexing. Okay, it allows us to access the data by performing slicing and indexing, the same concepts. Okay, slicing, what does slicing means? Accessing a range of values, multiple values will be slicing. Indexing is nothing but accessing a single value. Okay, whenever you want to access a single value, it means indexing. We are performing indexing there. Then columns from in-memory data objects can be deleted. We can also delete the columns and we can insert the columns. Okay, so how and all you'll understand. When you go to the hands-on part, you'll understand how the columns can be added, how they can be deleted from the objects of series data frame. Especially series and data frame is what we are focusing on, guys. Right? Yes. So this is about the key features of pandas. Let me, talk about the data structures that are available. Pandas help us to store the data in using two different data structures. Okay, what are they? They are nothing but series and data frame. They are series and data frame. So what is a series? What is a data frame? Series is nothing but it's a part of data frame. Okay. So how can you assume series is? It is nothing but it is a part of data frame. But in order to understand again data frame series, let us go and deep dive in it. Yes. So I'll start with the first data structure. It is series. What is series? Means series is a one-dimensional array. It's a one-dimensional labeled array. It is a one-dimensional labeled array. What is the purpose of series? It helps us to store or hold homogeneous data. The same type of data can be stored. Okay. And what are the different data types that we have? Int, str, float, or any Python related, objects like list, tuple, okay, then dict. So if you take the data, the object belonging to any of this type, it helps us to store the different types of data. But remember one thing, series is a one-dimensional object in pandas. Okay, and what is the purpose of it? It helps us to store the data. Right. So we have an access label within the series object. It is called index. Okay, which helps us to give a value for each and every value present in the series object. We have an index for all the values. You can assume series as a column in Excel sheet. I hope all of you are aware of Excel sheets. Yes. What do you mean by Excel sheet? Excel sheet is nothing but it is similar to a table. Am I right? Within the Excel sheet, you'll observe rows. The horizontal one are called rows and the vertical one are called columns. So series is nothing but one column from this table. One column is called series. Okay. So that is why it is a one-dimensional object. Okay. So you can have multiple rows. You can have multiple rows, but the number of columns are fixed. It is series means one column only. And coming to the series object, other values, can we change the values in a series object? Yes. Series objects are mutable, guys. They are mutable. Okay. And they help us to store homogeneous data. We can store homogeneous data within a series object. What do you mean by homogeneous data? Data which belongs to the same type is represented as, is called as homogeneous. Okay. What if you try to store different types of data? Still it allows us to store the data by treating the type as object. By treating the data type as object. But in general, a series object will store homogeneous data. This is very important. Right? So this is all about series. But let us go and understand how to create a series object. What do you mean by series? Series is a one-dimensional object in Python, in Pandas especially, right? So a one-dimensional object which helps us to store homogeneous data means the data of same type. And the type can be int, float, bool, or complex, str, whatever might be the data type, it helps us to store the values. And can we change the series objects? Yes, we can. We can. Series objects are mutable. Okay. So let us understand the syntax for creating a series object. How can I create a series object is by using the syntax. What does the syntax is? The syntax is pandas.series. Pandas.series. So, like how we have used numpy instead of, in front of the functions from the numpy. If you remember in the last 3 days, we have used multiple functions. Numpy.array, numpy.arrange, numpy.ones, numpy.zeros. Am I right? Numpy.delete, numpy.sort. So we have used multiple functions from numpy. And how did we actually come up with? We imported numpy as np, then we were using the function from numpy. In the same way, when you want to use series function from pandas, the syntax will be same. Pandas.series. It is pandas.series. And if you observe properly, series function, the first character of the series function is in uppercase and rest of the characters are in lowercase. So only if you keep the series function in this way, it identifies that it is a series function. Python understands, the PVM understands that it is a series function. If you change the case, you'll get an exception. Okay. So don't try to change the case because Python is case sensitive. What does the syntax say? The syntax says object, series of object, comma, index, comma, d type. So that means we have 3 parameters. What are they? Object, index, and d type. What are these parameters? Let us understand them. Object is referring to, the type. Either we are passing the values related to int type or float, complex, bool, str, bytes, byte array, range, list, end array, dict, etc. So here if you see, I have passed all the different type objects, but you cannot go for set type. You cannot go for set and frozen set. The reason behind why we cannot pass a set or frozen set object into the series function is they are unordered. They are unordered. Since they are unordered, you cannot pass them into the series function. Right? Next to the object, we have index parameter. What does this index parameter represents? It actually represents the position of the values. Okay, so it represents the position of the values in the object. Within the object, you'll have the values. Yes. For each and every value, there will be a position. So that position is, given by the index number. That is given by the index number. Okay. By default, we know that the index starts from 0 till n minus 1. Till n minus 1, the index continues. What does n represent here? N represents the number of values. Say if I'm trying to store 5 values within a series object, the index starts from 0. So till where I have the index? Till 4 only. Because 5 objects. The number of objects the number of values that I am trying to store are 5. So the index will stop at n minus 1. 5 minus 1 is 4. So the index will be till 4. Right? So by default, we have these indexes, but still you can customize the index. That is an added advantage, a key feature coming for, the data structures in Pandas. And what about the D type? D type obviously represents the data type. And here are the list of, data types. And if you see here, all of them are from C language, guys. Int 32, int 64. They are not actually the native data types of Python. Okay, they are from C language. Anyways, let us not go into it. So this is how we use the syntax of series and we build the objects related to series. This is what we do. So let us go to the hands-on and create the series objects. Let us go and create the series objects. I'll start. I'll go back to Spider. Right. So first of all, before using the functions from Pandas, ensure that you go and install Pandas. How do you install Pandas? Using the command, using the syntax. What is the syntax? The syntax is pip install pandas. This is what the command says. Okay. So when you want to install, you cannot keep the line of code here. This command will not execute when you try to, even though it will execute, but you better keep it here in the console and then click on enter. When you click on enter, what happens is it will install pandas. This syntax, this command will install pandas. I already installed pandas, but I'm showing you, no, I'm doing it for you. So if you observe here, there is a red button, which means it is under execution. Now the execution got completed. So that is why you see the button changing to the gray color. Right? So the execution has been done. In my case, I have already installed a long time back. If you see the message, a requirement already satisfied is what you'll observe. That means I have installed pandas in my local machine. I already have pandas. Where do I have the pandas? In this directory. So in the C drive, within a folder called users, in a subfolder called user, then in a subfolder called Anaconda 3, then subfolder called lib site packages, I have pandas of version 1.4.4. Okay, so this is how you have to understand, if you have already installed, you'll get a requirement already satisfied message. If you did not install pandas, you know, you will see the pandas getting installed. You'll observe the messy, you'll observe how the pandas is getting installed. But for me, it is already done. So I need not worry about it. I can directly go and import it. What am I doing in line number 6? From here onwards, I want every one of you to interact with me. Okay, I'll be asking you questions and you're supposed to answer my questions. What are we doing in line number 6? Come on guys, what am I doing? We understood that we are going to create series objects. We understood how series objects can be created. So let us start creating the series objects. Right. So what exactly are we doing in line number 6? We are importing pandas. Am I right? Yes. We are importing pandas as PD. Okay. If you observe line number 6, I am using two keywords like import and as. What are import and as? Both import and as are keywords. They are keywords in Python. Okay, which are nothing but reserved words in Python. What does import keyword does? It helps us to import a package or a module. Okay, so here in line number 6, I'm importing pandas. Okay, I'm importing pandas. Next to that, I'm also giving an alias name as PD. Good. I'm giving an alias name as PD. Again, you might get a question. Why PD? Why PD? Why not say NEUT? Can I also provide an shortcut name as NEUT? Will that execute? What do you say, guys? If I say import pandas as NEUT, will it execute or not? Yes or no? Yes. Yes, it will execute. Okay. So, irrespective of the name that we are coming up with, it will execute, guys. It will. Okay. See, even in the last class, when we are importing NumPy, every time we are giving an alias name as NP. But have you ever tried giving other name? Giving other alias name for NumPy instead of NP? Why don't you try your name? Provide your name and give your name as an alias name for NumPy and execute the code. It will run. It will execute. It will execute. Okay. So if your question is like why PD, or let me do one thing. Majority of our folks got confused. I see that all of you saying no. Let me change it to NEUT. What did I do? I have changed the alias name to NEUT. Next era Unitech, our organization name. Okay. So now your answer is no, right? But it will execute, guys. See, it will execute. The reason behind it is, what is NEUT? It is an alias name for pandas. See, like you have your original name and your nicknames, right? So even though if I call you with your nickname, will you respond or not? Yes, you do respond. Am I right? So what I am trying to do here is, I am trying to explain you Why PD or why NP? Instead of PD, NP or any other names, if I provide any other name to the alias names, still it executes. But the only thing that you have to do is every time that name should be used as prefix. Okay. So if your question is like why PD or why NP, this thing I have already communicated last time itself. Okay, I am repeating one more time. These alias names for pandas, numpy, PD and NP are universal standard. What do you mean by universal standard? That means you go anywhere in the globe, on the earth, you go anywhere, okay, when you refer pandas, okay, if you observe any of the Python scripts, if anyone is trying to import pandas and if they are providing an alias name, they'll come up with PD only. The reason behind that, it is universal standard, which means, say, if I'm trying to understand the code that was given by a other person, assume my colleague, okay, and he or she have included importing pandas as PD, okay, they have included pandas, importing pandas as PD as one of the line in the script. I can immediately understand PD is nothing but pandas. I can immediately understand PD is nothing but pandas. The reason behind it is universal standard. But what if my colleague, instead of keeping it as pandas, if she or he keep it as KD, I have to go back and I have to look at the line. Till then, I will not come to know what is this KD. Am I right? Exactly. So that is why, we'll follow the universal standard names. Wherever you go, Pandas has the alias name given as PD, NumPy NP, Matplotlib PLT. In this way, there are some universal standards. That is the reason behind just following the same alias names. See, if I give the same code to a person who is living in some other country like Australia or say US, okay, so if he or she goes through this line of code, they need not go back and check what is PD. They can understand that PD is pandas. Right? I hope you're getting the point. But instead of PD, if I say NEUT, assume that I have imported pandas as NEUT. So this line of code will be like NEUT dot series of list LST. So if the person who is residing in other country, okay, if they are going through the code, if they found that NEUT dot series, what is this NEUT might be the question. Okay, so then they'll go back and they have to understand from scratch. So that is why, we have some universal standards fixing, the standards. We follow these universal standards to maintain the professionalism. We maintain, a kind of professionalism. We go with the universal standards. So this is the story behind PD and NP, guys. So even when you are importing pandas or numpy, just maintain, just get habituated with the word, with the alias names PD and NP. Right. So I hope it is clear. I'll proceed. Now, once again, I'm importing pandas, but this time as PD. Not with NUT, I'll go with PD. See, it executed for both the cases. If you observe, it executed in the both the cases. But if whatever the alias name that you are giving for pandas should be used from the next line. Okay, if I keep it as PD, I should refer pandas as PD only. If I give the shortcut name, alias name as NEUT, I have to use NEUT for referring pandas. Okay, so that is how it was designed. Now, let me import NumPy. What is the purpose of NumPy? NumPy is used for, what is the purpose of NumPy? Advanced calculations, mathematical calculations, we import NumPy. Okay, so I'm importing NumPy as NP. Done. Both the packages got imported. Now I'll start the hands-on part. What we are doing in line number 8? What are we doing in line number 8? What is this object called? I see the elements got organized in a square braces and all the elements are comma separated. So this has to be a list object, right? So I'm defining a list object and I'm storing in a variable LST and I'm storing it in LST. List is the type. So it is the list object. What is the size? 6. Okay, so we have created a list object of size 6. Perfect. Then next to the line, I'm using series function from Pandas, pd.series of LST. pd.series of LST. What is this LST? LST is nothing but list. So that means I'm using a list object to create my series object. What is series? Series is a one-dimensional object. So this list will be converted as a one-dimensional object. That means only one column. It contains only one column where it can have multiple rows. So can you tell me what will be the size of the series object? Just go for a try. Go for a guess. How many elements we have? 6. So the size will be 6 comma. See, S is a series object and the size will be 6. Why it is 6 comma? Because we have 6 elements. We have 6 elements. And if you observe properly, how many columns? Only one column. And does all the elements of the series have index numbers? Yes. By default, the index starts from 0. By default, the index starts from 0 till the number of values minus 1. I have 6 values. So 6 minus 1 is 5. So from 0 till 5, we have the index. Clear? Right. So let me print this series object to the console using print function along with its type. Type function will return the type. So this is my series object where the first values, whatever you see, is representing the index, and next to that you have the series object values. Okay, what is the type? It is representing a series. It is representing a series. It is a series object. Right. Now, you guys have to respond. What are we doing in the next line? What are we doing, guys? Are we creating a list object? Yes. The same object. So just creating an object one more time. So storing the same variable. But what makes the difference between the previous line, line number 9 and line number 13? What is the difference, guys? What is the difference that you identify between line number 9 and 13? In 9, I don't see the D type parameter in series function, but I see the D type here. And I am defining the data type as float. Yes. So that means these values of the list will be converted as float type and then we are storing in the series object. So let me do it and let me print it. So what is the output? It is 10.0, 20.0, so on 60.0. But do we have actually the float values? No. All of them are int type. Okay. And since I'm using the D type as float, the values are getting changed to the D type as float. So that means I can also have a control on the data type. Yes. Perfect. Then the next example is taking a list of str objects, str values. All of these are str type values, right? So I'm having a list object of size 4. So these are my list. This is my list object and these are the values. All of them are str type. Now, next to that, what we are doing in line number 17, guys? What are we doing in line number 17? I'm using a function from NumPy. Should I keep it as NumPy? No. You should not use the word NumPy. Why? Because NumPy was called as NP. No more NumPy is called as NumPy here. The reason is we have already provided a alias name for NumPy as NP, and that is why you should always refer NumPy as NP. Okay, so NP dot array of LST. I'm using a array function from NumPy. So that means this list object will be converted to array type. So what will be the size of the array? Will it be a one-dimensional or two-dimensional or three-dimensional or n-dimensional array? Which type array will be created, guys? If I execute line number 17, it returns me a one-dimensional array. Why? I'm passing a one-dimensional object only, right? So this will return me a one-dimensional array. See? A one-dimensional array is what it has returned. Then I'm just printing the array along with its type. Done. It's an ND array. Okay, it's a one-dimensional array. And this array I'm passing to the series function. So I'm passing it to the series function. So the array gets converted to series. The array gets converted to series. So what happens? This will return me a series object. And let me print the series object. So what is the size of the series object? 4 comma y. There are 4 values. What is the index of these values? From 0 till 3. From 0 till 3, we have the series values index. Right. So far, the examples that you have observed, whatever the examples that you have observed, all of them are actually, we are working only on, we are trying to store homogeneous data. See, all of them are int type, integers. Here, float values. Here, str type. But in the next example, do you see all the values are belonging to homogeneous group or heterogeneous? Are they homogeneous or heterogeneous? Come on, guys. One value belonging to int, one belonging to float, and two belonging to str type. So this is an example of heterogeneous data. It is not homogeneous. Yes, it is heterogeneous. So I'm defining a list object which contains, the objects from different data types. Okay, done. Okay, the list object got created. I'll pass this list to the series function, and will a series object be created or not? Will it create a series object? Yes, it does create, the series object, even though if there is heterogeneous type values, even though the elements are heterogeneous, still it considers the data type as object. See, you'll observe the data type for these elements as object. Okay, so that is why it is allowing us to store the data. So what did we learn? Pandas series stores only homogeneous data. Am I right? But what kind of values do we have? Do we have all of them same? Say belong to the same type? No. But still, it considers internally all of them belong to the object data type. Okay. So that is where it is allowing us to store the values, even though if they are coming from different type. Let us go to the next example, guys. Then I'm taking the same list object. Then I'm printing the list object using print function to the console. Done. So what I'll do is I'll pass this list object to the series function to convert the list to a series. But additionally, I'm coming up with my custom index. I don't want the default index. We know that the default index starts from 0 and it goes to beyond, it goes till n minus 1, where n represents the number of values. But I don't want to go with the default index values. I'll customize it. How? By passing values for your index parameter in series function. So I'm passing the index values. It is ST number, name, marks, designation. Okay. So when you pass these values, what happens is, for these values, the index values will be used. Let me execute and let me print. See, we know by default the index number should be 0, 1, 2, 3. But what happened? I am customizing my index. Is that possible? Yes, it is possible. We discussed one of the key feature of Python data structures is it allows us to customize our index. And when I say S of ST number, what will be the output, guys? What is S? SE is a series object. So what does S of ST number written as? S of ST number should written as 10. Yes, it has to written as 10. Why? This is nothing but indexing. You are performing indexing on series object. Can we perform indexing and slicing? Yes, we can. So let me execute. The answer should be 10. Clear? Right. Then let me go to the next example. I am coming up with one more list object, but the list object that I am going to convert into the series object. Okay, I would like to customize the index. I don't want to go with the default index. It is 0, 1, 2, 3, so on. I'll go with the customized index values. So depending on the number of values that you are trying to store, accordingly you have to specify those many number of index values. Since I'm going to pass 4 values, I'll pass 4 values in index. So this 100, 200, 300 and 400 will be used for index. They'll be used as index values. So let me do it, guys. Done? Is that done? Yes. Let me open the series object. Yes. You'll observe the index values as 100, 200, 300, 400. And these are your values. Okay. I can also print to the console. I can print the results to the console. You'll observe the same values returning. It is going to return us the same values as output. Clear? Yes. So far we created the series objects using list objects. Right? And array object. Now, let me create series object using dict object. Can we also create a series object using dict object? Yes, we can. When you try to do so, what happens is the keys that we have within the dict object will be used as indexes. Okay, within the key dict object, you'll have keys and values, right? So these keys will be used as index values in the series object, and the values will be kept as it is. The values will be used as values, right? So let me do it, guys. I'm importing pandas as PD. Then what we are doing in line number 45, if we observe, this is a dict object. See, the data is represented in the form of key and value pairs, where keys and values are separated by colon and key value pairs are separated by comma. So this is nothing but a dict object. I am defining a dict object and I am storing in D1. I am storing in D1. Let me open this dict object. See. For dictionaries especially, you will not observe index. You will have the first column as keys. You will have the first column as keys. There is no index. The keys will be used as index and they help us for indexing. Keys will be helping us for indexing. So the same keys will be used as index values in series objects as well. So what am I doing in line number 47? Whatever the dict object that we have, I'll be passing it to the series function. Okay. So when I pass it to the series function, the keys will be used as indexes and the values will be used as values only. So can you tell me what will be the size of S after executing line number 47? Come on guys, what will be the output for line number 47? 47 is going to return as a series object where the size of the series object will be 4 comma. It will be 4 comma. Let me execute. See, I'll open this object. If you observe in the index, do you observe the numbers? No more you'll observe the numbers. You'll observe the keys sub 1, sub 2, sub 3, sub 4, subjects. Subject 1, subject 2, subject 3, subject 4. And the corresponding values for these keys, Python, Java, data science, ML. Okay. So that is how a dict object will be used and it will be converted to a series object. I can also print it to the console for better understanding. Yes. Done. Clear? In the same way, we have one more example. So you guys have to do it. What will be the output for this code? What we are doing in line number 50? In line number 50, we are actually creating a dict object. We are defining a dict object which is of size 4. Okay, there are 4 key value pairs. And I'm also printing this dict object to the console. Done. Then I'll be using it. I'll be passing this dict object inside the series function. Okay. So when I pass the dict object to the series function, the keys that we have in the dict object will be used as index values. They'll be used as index values and it will return me a series object. Observe guys. So this is my series object. Clear? So you can use any object, any Python object, and that object can be passed into the series function for creating a series object, right? So this is all about series. The next topic that we have, the next data structure that we have in Pandas is data frame. So let us understand, the concepts related to data frame. What is data frame? We understood series is a one-dimensional object in Pandas. In the same way, let us also understand what is data frame. Data frame is a two-dimensional object, guys. In Pandas, data frame is a two-dimensional object. And what is the purpose of data frame? It helps us to store the data organized. We can have the data in an organized manner. Okay. In short, data frame organizes the data in table format. Within how you observe a table, in a table format, the data gets organized. So what is a table? Table is nothing but a collection of rows and columns. So that means data frame is also similar to table. Okay. So this is representing a table which contains rows and columns. Within these rows and columns, you will observe the data being stored in an organized manner. Okay. Then coming to the columns, you can have multiple columns in a data frame. In series, only single column. In data frame, n number of columns you can have. Right. So these columns of a data frame can have same type or different type, values. The values that are part of the columns. Okay. So these columns can contain, the columns can be of same type or different data types. Anything is accepted. And data frame is also a mutable object. Even though after creating it, we can change, we can edit the values. Okay, even the size also can be changed. That means I can add a column. See, for suppose if I have 100 rows and 10 columns, is that possible to add a column? Yes, we can add a column. That is why it is clearly written. The size of data frame can be mutable. I can add a column. When I add a column, it will be 100 by 11. I can delete a column. When I delete a column, it will be 100 cross 9. So in this way, it allows us to change. In the same way, I can remove a row. A record can be deleted. 10 records can be added. So the size of data frame is mutable. But how should we create data frame objects in Python? We understood data frame is a two-dimensional object. But for creating data frame, there are multiple approaches, guys. There are multiple approaches. So let us understand all these approaches one by one. So when you want to create a data frame object, okay, how can I do it? There is a function within Pandas called data frame function. Okay. So this will return me an object of data frame. It will return me an object of data frame. So what are the different ways of creating data frame are? So to this function, we can use a list or tuple object. Like how we have passed a list object so far for creating a series. In the same way, we can use a list object or a tuple object or a dict object, or we can also use series object, end array object. If not, you can directly pass a CSV file. What is CSV file? CSV file is nothing but comma separated values. Okay, if your data is stored in a file format within your file, okay, like .csv or .excel, I hope you are aware of the file formats, right? So if the data is stored in any of these files, you can still, define your data frame object, because we have functions from pandas, okay, especially the data frame function, and there are few more functions which helps us to, build a data frame, which helps us to build a data frame. So let me start creating data frames by using all these different approaches one by one. Then, but before that, I have to go through the syntax of data frame, right? Like how we have a syntax for series, in the same way, we also have a series for data frame. Let us understand the syntax for data frame, guys. Pandas.dataframe. It is pandas.dataframe. Data frame is representing a function. And if you observe the characters of data frame, is it in lowercase? No. Is it in uppercase? No. Is it in proper case? What do you say, guys? Is it the characters that you observe in data frame, are they in lowercase or uppercase or proper case? To which of these category the data frame function falls? I can clearly understand it is not, the characters are not in lowercase, not in uppercase, and not in proper case also, right? Because proper case means only D have to be in uppercase and rest of all the characters should be in lowercase. Am I right? That is called proper case. But the data frame that you observe, the function data frame from pandas, is not in proper case. I see both D and F. Very careful, because especially when you are typing your code, your exceptions, your errors will be because of the case only. Okay, when you are typing the code, assume that if you have typed data frame in proper case, will it execute? No, it will not execute. So pay attention. This is called camel case. This is called camel case. And majority of the functions in Python, they use camel case only, guys. Especially the functions coming from these third-party APIs. Okay, like Pandas, NumPy. Okay, then we have sklearn, matplotlib, cborn. So from these packages, whatever the functions that we are trying to use, they will be in camel case. So be careful. What does camel case means? So camel case is representing, it means the first word of every particular word will be in uppercase and rest of the characters will be in lowercase. See, data, D is in uppercase and rest of the characters in lowercase. Frame, frame is also a word, right? So F is in uppercase and rest of the characters are in lowercase. So this is called camel case, and the parameters that we have within the data frame function are object, index, columns and D type. Hold on. In series, we have object, index and D type. So what is the additional parameter that got added? Columns. The additional parameter that got added is columns. Right? So let us understand all these four parameters quickly. Object is representing the type of object that we are passing. Okay, you can pass a list object, tuple object, dict object, series, ND array or CSV file can be passed. Okay, so the different objects can be passed. And coming to the index, index is representing the row index, guys. Index parameter represents the row index. By default, it starts from 0. We know that. Till n minus 1. What is n representing? N represents the number of values within the data frame object. Then coming to the columns, columns represents the column index. Index represents the row index. Columns represents the column index. Same. By default, it starts from 0 till n minus 1. What is n representing? The number of columns. If I have 10 columns, the index will stop at 9. Right? And finally, the D type. So the D type is representing, the data type of the values for the columns. Making sense? So let us use the same syntax and create data frame objects by passing different objects into it. Let us do it, guys. So I'll go to the hands-on part for data frame. I'm importing, first of all, I'm importing pandas as PD. Okay. So import pandas as PD will import the pandas. Done. Pandas got imported. Yes. Next to it, I'm creating a list object. Okay. So within the list object, there are 4 elements. So I'm storing the list object in LST variable. So LST is a list of size 4 and these are the values. What are we doing in line number 60? 60. In line number 60, we are passing the list object to the data frame function coming from pandas. PD means pandas. Pandas package. So data frame is a function from pandas and I'm passing the list object to the data frame function. And you know what happens? The list will be converted as a data frame object. And this data frame object we are storing in DF. See? What is the size of DF? Is it 4 or 4 comma 1? It will be 4 comma 1. Why? We know data frame is a two-dimensional object. If it is a two-dimensional object, it should contain 2 dimensions. 4 represents number of rows, 1 represents number of columns. So let me open this data frame. So how many rows? 4. How many columns? 1 column. By default, the indexing is starting at 0. And for rows, it is 0. For columns also, it is 0. Okay. Irrespective of whether it is a row or column, the index by default starts with 0. And it ends at n minus 1. Okay. This is very important. Let me print this data frame df object to the console. So this is my data frame, guys. The size is 4 comma 1. It will not be 4. 4 comma represents, it is only one dimensional. But is this one dimensional? Is data frame a one dimensional object? No. It is a two dimensional object. Right? Yes. So what are we doing in line number 63? Again, I am defining a list object, but this is a nested list. It's a nested list object. Right? Yes, this is a nested list object. And I'm converting this list object to data frame. I'm passing the list object to the data frame. Can you guess what will be the size of data frame? DF in line number 64. What will be the size of DF in line number 64? Come on guys. We know the size of LST and I'm passing that LST to I'm passing this LST to the data frame function. So tell me what will be the size? Just go for a guess at least. Okay, then let me reveal it out. It will be 2 comma 4. See, this is how it will return me a data frame. No, that is where majority of the people get confused. Here, if you observe properly, I'm passing a nested list. It is not a list, right? It is a nested list object, and I'm passing this nested list object to the data frame where it considers the first row as it is in the first row in the data frame object, and the second list will be considered as the second row in the data frame object. Let me open it. See, the size will be 2 comma 4, 2 rows, 4 columns. Okay, if you observe properly, the indexes are 0, 1, 0, 1, 2, 3. By default starts from 0. Clear? Good. In the same way, again I'm taking a nested list object. Yes, I'm taking a nested list object and passing to the data frame function. I can comment here now. What will be the output? Here it will be 4 comma 2. Let me print it. See. In this case, in this example, the output will be 4 comma 2, 4 rows and 2 columns. Making sense? Yes. Let me take the same list again, the same list object I am taking again, but not just passing the list object to the data frame. Let me customize my index values. Let me customize my index values. I don't want to go with the default index. I'll pass my index values saying that 1, 2, 3, 4. And even for columns, I don't want to have the default index values for the columns. I would like to have two different names like roll number and name. So that will be given as the column names, guys. See. I have customized row index as well as column index. For columns, I have provided the column names, roll number and the name of the student or the employee, whomever it might be. Clear? One more example. But what are we doing here? What kind of object it is? It is a tuple object. Because I see the elements, the values are organized in parentheses. So I see this is a nested tuple in a tuple object. Am I right? Yes, this is a nested tuple object and we are storing in TPL. Done. I'll use this nested tuple object for passing into the data frame function, and the index values that we have here are, I'm coming up with the index values, customized values for the rows 1, 2, 3, 4, 5. And for columns, also I'm coming up with the customized index. It is name and age. So the columns will be renamed as name and age, and that will return me a data frame. This is going to return me data frame. See? Customized index for rows and customized index for columns. What is the size of the data frame? It is 5 by 2. If we observe, DF is a data frame. The type is data frame. Clear? So far we have just passed the objects of list and tuple. Let me pass dict object. Let me create data frames using dict object. As usual, within the dict object, we'll have the keys. So these keys will be used as the column names. See, the keys that we have within the dict object will be considered as column names. And the values will be considered as it is. The values, the data. Okay. So what am I doing? I'm importing pandas as PD. Then I'm defining a dict object. If you observe properly, I'm defining a dict object. Okay. How many key value pairs you notice? I see 3 key value pairs. Names is one of the key. Subjects is key 2. Ages is key 3. And the values are stored in list objects. See, I'm storing the values in the list. So let me define my dict object initially. The size of dict data will be 3 because 3 key value pairs. 3 key value pairs is what you'll observe. Right. Now this dict object, if I pass to the data frame function, can you guess what will be the output? That's clear. No, we have understood that the keys like names, subjects and ages will be column names. So we'll have 3 columns. Done. But what about rows? Rows will actually take these values. How many values you observe in each column? 4. So the size of the data frame DF in line number 89 will be 4 comma 3. Let me print it, guys. See, if I print the results, 4 rows and 3 columns. What are the column names? The column names are nothing but the keys from the dict object. From the dict object, whatever the keys that we have considered was written as, the column names. But for rows, the index is by default from 0. So I'll consider the same line of code by customizing my index. When I want to customize my index, so it will be like, I'll provide the index values for the rows. So what will be the difference between the previous line and this line? Only the index is what we are changing. See, I'm just changing the index. That's it. Clear? Right. So we understood how to create data frames using both list object, tuple object as well as dict object. Now let us create data frames using series objects. Is that possible? Yes, it is. Let us do it. I'm importing pandas as PD. Then, first of all, let me create a series object, guys. Let me create a series object. For creating series object, I'm using pd.series function. Okay, where I'm passing a list to the function. So this will return me a series. Tell me the dimension for sData. No. In case of series, the dict object that we pass, only there the keys will be used as index. But in case of data frames, okay, in case of data frames, and if you are passing a dict object, the keys from the dict object will be used as column names. What are column names? Again, the index for the columns. Right? So that is the difference that you'll notice here. So I'm creating a series And can you tell what will be the size of S data? S data will return me the size as S data will be a series object of size 4 comma, because there are 4 values. So the output should be 4 comma. See, it is a series object, size is 4 comma. So this series object I am passing to the data frame function. I am passing it to the data frame function. When I pass it to the data frame function, what happens? Since data frame is a two-dimensional object, so this series will be converted to a two-dimensional. Can you guess what will be the output? What will be the size of the data frame DF? It will be 4 comma 1. Simple. One column is what we are passing, right? So we should have two, numbers, two dimensions representing data frame, because data frame is a two-dimensional object. 4 represents number of rows, 1 represents number of columns. That makes the difference. See, you observe series and data frame. The same series object I have converted it to data frame. But when you compare the size, I can clearly distinct. I can differentiate what is series, what is data frame. This is a data frame, this is a series. How can I can differentiate? A data frame will contain two dimensions, whereas series will contain only a single dimension. Right? Yes. What are we doing? I'm taking a dict object, and this dict object I'm converting it to series. So tell me what will be the size of the series object that we are creating here. Only in case of series, what happens is, when you are using a dict object especially, the keys will be used as index values. The keys will be used as index values in the series object. And whatever the values that we have within the dict object will be used as values only. So when I pass this dict object to convert it as a series object, int marks and next marks will be used as index values, guys. Within the series object, these two will be used as indexes. And the values will be the first list and the second list. Can you tell what will be the size of the S data? Size of the S data series object? It will be 2 comma. It will be 2 comma. See, why 2 comma? We are just passing only two values, right? Int marks, X marks will be used as indexes. And both of them have values. Yes. So the values, how many values? Two values. Making sense? See. This series object, I'll be passing it to the, okay, let me print the series object first of all. Done. Now I'll pass this series object to the data frame. Can you guess what will be the output? I'm passing the series object to the data frame. Yes. Earlier we have tried using a list object, but now we are trying with a dict object. What is the size? It is the same, 2 comma 1. See, the difference. This is a data frame and this is a series object. DF is a data frame object, whereas S data will be a series object. But what if I directly pass? See, I'm converting this dict object to series, and this series I'm passing it to data frame. The output is 2 comma 1. What if I directly pass the dict object as it is? I'm taking the same dict object. I'll directly pass it to the data frame. If I directly pass it to the data frame, can you guess what will be the dimension for df? What will be the dimension for the df? Come on guys, what will be the dimension? It will actually, when you are passing a dict object directly, the keys that we have in the dict object will be used as column names. So int marks and x marks will be used as column names and the values will be written as the values. So the output for df will be 4 comma 2. Yeah, obviously data frame means 2D object. I am expecting, this one, the dimension, the size. 4 comma 2 will be the output guys. Clear? Right. Let me pass n-dimensional array objects. Let me pass the array objects. We tried using list, tuple, dict objects and series objects. Let me use nd array objects for creating data frame. Before that, I'll clear my entire memory. Then I'll start, I'll import pandas once again because as I'm clearing up the memory, done. So what am I doing? I'm importing pandas, then I'm importing numpy for data manipulation and for mathematical calculations. We use both these packages, right? What is this? This is a list object. Concisely, it is a nested list object. Done. We have a nested list and I'm converting this list to array. Can you tell me what will be the output of line number 118? Which type array will be created? It will return me a two-dimensional array. If you remember, I'm passing list object to array function from numpy. But if you observe, it's not a just array, it is a nested list. Okay, as I am passing a nested list, this will return me a two-dimensional array. What will be the size of this two-dimensional array? It contains 3 rows and 2 columns. Let us do it. See, 3 rows and 2 columns. Now, I'll use this array, I'll pass it to the data frame function and this will return me a data frame. This will return me a data frame. So this will be passed as it is, the array will be passed as it is and it is going to return us the data frame in the same way. Even that size of the data frame will be same guys, 3 by 2 only. See, like whatever the manner that we passed, in the same way you are going to get the data frame created. So to this data frame, okay, the same line of code, I'm customizing the index for the columns. I'm customizing the column indexes by passing two values for columns parameter. So instead of 0, 1, you'll find int marks and x marks, internal marks and external marks. See, you'll observe internal marks and external marks as output. The same line of code, but additionally we have added columns parameter in the data frame function. Right. Next to that, finally, let us also pass let us achieve a data frame using CSV file. Okay. So for that, I have to show you that CSV file, right? Yes. See, if you observe, I'm importing pandas as PD1, but still it will execute. It will execute. Now, let us read the data that we have in a CSV file. So for that, I'll initially show you the CSV file. So what is the file that we are using? Student marks. So this is my CSV file, guys, in which I have the data. Okay. So this data is related to student marks. Marks of the students. Okay. Some random data that we have collected and stored in a CSV file. So this data I'll directly load into the Python memory, and if you observe, this will return me a data frame. Okay. So what am I doing is I'm using a function called read underscore CSV. In order to read the data that we have in a CSV file, we use a function called read underscore CSV. Okay. So what does this read underscore CSV does is whatever the path, this is nothing but the path, the location of my file within the local machine, within my system, I have the CSV file at this location. So you are supposed to pass, you are supposed to keep your location within the function. When you specify the location, it goes, the PVM goes through this location and reads the content, whatever the data that is available in the file, it reads, and that data will be stored to the variable df. If we observe properly, df will get the same data, but the type for the df will be data frame. See, I have executed. Df is representing which type? It is a data frame. What is the size of it? 13 rows, 8 columns. Can we open it? Yes. So this is my data, guys. You compare, you'll find the same data. The same data from a CSV file we have read into Python. How did we store it? In data frame. Because data frame is a two-dimensional object. Even if you observe here, the data is stored in a two-dimensional format, in a table, right? So by default, the index is from 0 till we have 13 students data. So 13 means the index will stop at 12, and the column names were also provided within the data set itself. So the same has been read and we have it in Python's memory now. So if you go and especially if you want to check the type of df, it will return you data frame. It will return you data frame. Okay. Then when I say print of df, it will print the content, whatever the content that we have, the entire table will be printed, guys. So if you observe here, the entire data will be printed. See, the same data, whatever the data that we have in DF will be printed. Done? Yes. So these are the different ways for creating data frames. Next to data frame, we have group by. Okay. So let us understand what does this group by does actually. Okay. So group by is a mechanism in Pandas which help us to, group the records. It helps us to break the data frame into different groups. So we'll understand how we are able to perform the group by. We have a function called group by within the pandas, and this actually, it will break the data frame into multiple groups depending on the column that we specify. right? So I'll go with the examples because from here onwards, the examples are very simple, right? So I'm importing pandas as PD. Then I'm coming up with a list object. If you observe here, what do we have? List of tuples. List of tuples. So I'm storing all these list of tuples in a variable called employees. Okay, probably that means we are storing the details of employees. So let me do it. Done. So what is the size of the employees? It is 10. It is 10. Now I'll go and create a data frame object. How can we create? If I pass this list object to the data frame function, I'm done. But additionally, if you would like to specify the column names, for the columns parameter, specify the column names. See. Okay. So I have specified the column names as well. Then I'll execute. Let me go and check. Is the data frame got created? Yes. Of 10 employees, the data is ready. We have the data frame ready. Okay. So how many columns? 4 columns. I'll use a function called set underscore index. What does this set underscore index function does is, whatever the column that we use, that specific column values will be used as, index. These values that we have in the ID column will be used for setting the values for index. So whatever the index column that we have will be used as the index values. So when I execute line number 155, it becomes 10 comma 4. The reason why, the ID column values will be used as index. See, no more you'll find index. You'll find ID. Why? The ID column that we have used it as index. Even that can be done. We can also customize our index. One of the key important feature in Pandas is customizing your index. Okay, that can be done, guys. And I can finally display the data frame. Done. Okay, right. So the same code that we have here, I'll just exclude it and I'll directly go to the group by function. Let us understand how we are able to perform the grouping. Can we group by? Can we group the records? Yes. You can group the records using the function called group by. This is also available in Pandas. Okay. So on which I'm performing group by on DF. What is DF? Data frame. Okay. So on this data frame, I'm going to perform group by and using which column? Using the column city. There is a column called city. Yes. So within city, how many distinct values you observe? I see Sydney as one of the city, Delhi, then Mumbai. Yes, only 3 cities. So that means when I execute line number 179, it will return me 3 distinct groups. One is for Mumbai, one is for Sydney, and the other one is for Delhi. Right? So depending on the column that we specify the group by function, okay, so this will actually, split the data frame into different groups. And where did we store the output? We stored it in group obj. If you observe, what is the size of group obj? 3. When you try to open it, you can't understand anything, guys. You cannot access the values, whatever the content present in the variable in this fashion, right? So that means in total we have 3 groups. How can I get the data? How can I access the values is using loop. using loop. So I'll be using for loop for accessing the group names and the rows. Okay. So I'm using the for loop, and which will initially print the group name, then followed by the group content. What will be the group name? Group name will be nothing but the city name. Okay. Then it will print the rows one by one. So let me execute this for loop and see the groups. All the three groups. What is the first group? Delhi. Yes, the group name is Delhi. Okay. Then under Delhi, we have 4 different records. Out of 10, 4 of the employees, they belong to Delhi. And how many of them they belong to Mumbai? Only 3? Yes. This is the second group. What about the third group? It is Sydney. Obviously, there should be 3 employees because in total we have 10 employees. Yes. So 4 in Delhi, 3 in Mumbai and 3 in Sydney. That is how we can perform the groups. Grouping can be done. Right? Yes. Then let me take the same example again. But this time I'll do the same till here. It is again the same line of code. Okay. I'll directly introduce you guys to the other functions that we have within the group by. Okay. So far whatever we have done till here is same. Okay. It is same. We were able to get the group names and the content, the different records that we have in each group. Now, what if I say, df dot group by of city dot first? What does it mean? It means you are taking the entire df, the data frame, and you are performing the group by based on the city column. Done. Okay. And from all the groups, if you want to access the first record, we can directly go and use the the first function that we have. I can go and use the first function. When I say first, this will return me all the records, the first records from all the groups. See, I'll execute. Where are these records getting stored? They got stored in first row df. Even that is a data frame. Let me print them, guys. If I print them, you'll get clarity. So from each group, the first record will be returned. See? There is also one more function called nth. This nth function will return as, the specified index value. Whatever the index that you specify. See, I want the index 1 row. What does index 1 means? Index 1 means the record 2. So this will return me the second record of each distinct group. Nth function will return me nth record of every group. So the n that you specify is nothing but the index. It's nothing but the index. So when I say nth of 1, this will capture the second record. This will capture the second record from all the 3 groups, and it gets returned. And we also have size function. We know size function will return us the shape. The shape of each group will be returned. Each distinct group has a shape. Yes, we understood clearly. Delhi has 4 records. Mumbai has 3 records. Sydney has 3 records. So that will be returned by the size function. Size function will return the size of the number of records present in each distinct group. See. And we also have get underscore group function. What does this get underscore group function does is, whatever the group that you want to get, if you want to get the complete records of a specific group, okay, when you specify that group name alone, it will return you all the records of that specific group. So get underscore group function will return me the records for Mumbai group. See. So these are the records belonging to Mumbai. These are the records belonging to Mumbai. In the same way, if I want other group, I have to go and specify the name of the group in the get underscore group function. So these are some of the important functions that we have within the group by. Okay. So what does group by does? Group by actually performs the grouping. Based on the column that you specify, the grouping will be done, and it will actually break or split the data frame into multiple groups. Right. We have, from here onwards, we have majority of the functions, okay, within the pandas. Okay, all of this is related to the theory part. Let me talk about each and every function. Okay, so I'll start with the head function. Initially, we have a few attributes, functions that help us to access the data of data frame. Okay, how to access the data from a data frame is, when you say data frame object dot head function, this is head function, guys. Head function will return you generally the first records. Okay, how many records? Depending on the number of records that you specify. If you say 100 records, the first 100 records will be returned. If you say 1000 records, 1000 records will be returned. What if you don't pass the number of records? Assume. Then by default, 5 records, the first 5 records will be returned. That is the purpose of head function. Like how we have head function, in the same way we also have tail function. What does tail function does? Tail function will return the last records. Head will return the first records, tail will return the last records. Again, in the same way, depending on the number of records that you want, specify the number of rows. If you want the last 100 records, specify tail of 100. Okay. If you just want only 10 records, specify it as tail of 10. Okay. So that is how tail function will return as the last records. What if you don't specify? By default, again, the last 5 records will be returned. Done. And describe function. Describe function will return us the descriptive statistics of numeric columns. So within the data frame, you'll have both numeric and non-numeric. Yes. For the numeric columns alone, the describe function will return us the descriptive statistics. What do you mean by descriptive statistics is, it returns us the statistical measures like mean, standard deviation, count, minimum value, maximum value, 25th percentile, 50th percentile and 75th percentile values for all the numeric columns in the data frame object. Okay. Then shape attribute. Shape attribute will return as the size of your data frame object. When you want the size of your data frame object, you can just keep it as dot shape. Excuse me. Then can we also perform slicing? Yes, we can also perform slicing on the data frame object. When you say start comma start, column stop. This will return you, this will actually perform slicing with respect to the rows. Okay. In the same way, whatever we have discussed in slicing, by default start, stop and step. Depending on the values for these three, start, stop and step, accordingly the values, the rows will be sliced. Next to it, data frame object of column name. This will return you only the values of this specific column. It will allow you to access only the values of one specific column alone. What if I want to access the values from say 2 or 3 columns? See, when you want to get values of say 2 columns, so you have to keep it in this way. Column 1 comma column 2. So that will actually return you the values of both the columns. Then coming to the next line, what makes the difference is on the specified columns where you are actually accessing only the required column, say column 1 or column 2. On the output also you can perform the slicing. You can also perform the slicing on the specified number of columns. And iter rows function will actually iter along the records. Starting from the one, along the records it helps us to iterate. Now, let me explain you what does LOC and ILOC means. LOC is where, which means the location. Okay. We generally use the column names. In order to access the columns, we go with the column names instead of the column numbers, and we here in LOC both start and stop values, whatever we specify when you are using LOC, both start and stop indexes will be included, guys. They will be included. When they get included, yes. So they are inclusive. They are not excluded. Okay. They are inclusive, and with respect to the column names, you are supposed to use the column names for columns. You should not go with the column indexes. That is the main point for LOC. But when you compare with ILOC, the difference that you'll observe between LOC and ILOC is LOC represents location, ILOC represents indexing location. Okay. So in ILOC, start index will be included, but stop index will be excluded. Stop index will be excluded. But here, both start and stop are included. This is the first difference. And coming to the column names, in ILOC, we need not use the column names. The column names are not required for accessing the columns. You can go and use the column indexes. The numbers can be used. But here, column names should be used. So that is the difference between LOC and ILOC. LOC and ILOC. Right. Next to that, we have how to add a column name to a data frame. For a given data frame, can I add a new column? Yes. By just specifying it as data frame object of new column name. Whatever the new column that you want to add, specify the new column name, and you can go with the default value. What it means is, for the new column, this default value will be kept across the records. In the same way, if you don't want to go with the default value, if you want to keep an expression, you can also define your expression by adding the new column. So this will be the syntax. Can I also drop the columns? Yes. Not just adding, you can also remove the columns. We have drop function in Pandas. Okay. So this drop function can be performed on the data frames, which helps us to drop the columns. How can we drop the columns is, we'll specify the column name, guys. Whatever the column name that we specify, that specific column will be dropped. What makes the difference between line number 260 and 261 is, here the column will be dropped, but not permanently. Here we are not actually going with the in place operation. Whereas in line number 261, where we are dropping the column permanently from the data frame. In place is equals to true means within the data frame, the column gets dropped. Okay, so not just adding, we can also drop the columns. Next to that, can we sort the values in the data frame? Yes. There is a function called sort underscore values. There is a function called sort underscore values. Depending on the column that we have, that we specify, the values get sorted by default in ascending order. What if you want the output to be returned in descending? When you want the output to be returned in descending, you should specify ascending is equals to false. There is a parameter called ascending in sort values function. So within this function, if you specify ascending is equals to false, it will return us the values in descending order. Then there is a function called duplicated, which helps us to identify the duplicates present in the data frame. Okay, whether we have duplicates or not can be identified using duplicated function. Can we remove these duplicates? Yes. We can remove the duplicates using the function drop underscore duplicates. When you use the drop underscore duplicates function, it helps us to remove the duplicates from the data frame. So again, the difference between line number 271 and 272. You are dropping the duplicates and storing the results to a new object. But here in line number 272, the results, we are going to drop the duplicates permanently. It's an in place operation, guys. Okay, so that makes the difference. Identifying the duplicates can be done using duplicated function. Removing the duplicates will be done using drop underscore duplicates function. Right? Yes. And finally, how we have to export our results to a CSV file. See, assume this is my results. These are my results. Okay. And if I want to store these results to a CSV file, can I do it? Yes. You can store your results to a CSV file using to underscore CSV function. We use to underscore CSV function. Okay. Whatever might be your extension of your, so you have to specify. We are going to use to underscore CSV function. df dot to underscore CSV function means the data frame. Okay, the data frame results, whatever the data frame that we have, this data frame will be saved to a CSV file. That is the purpose of CSV, to underscore CSV function. Then within the function, what you have to specify? You have to specify the directory at which location in your local machine you want to save this DF data frame with the name of your file. See, E is representing the drive. Okay. And I want to store the output to a CSV file with the name student final data. So this is representing the name of the file. Okay. You can also store the CSV file to a text file .txt. So whatever the file that you want to store, the name has to be provided exactly. Okay. So to that location, it will go and create the file with the name that you have provided, and it stores the file. The data gets stored internally. The data gets exported. So what makes the difference between line number 278 and 280 is when you say index is equals to false, the index that we have by default you'll get guess. Okay, let me take this one. You will find the index. This is group by rate. Okay, so by default in data frames you'll have index. When you use this do 2 underscore CSV, even index also will be exported. When you say index is equals to false, this index will not be exported. The index will not be exported. That is the difference. But by default, index will be true. The index parameter that we have in the 2 underscore CSV function, it will be true. So when you execute this line, the index also gets exported. When you don't want the index, obviously index is not required. So when you keep the index is equals to false, it will not export the index values. Since you are going to store in a txt file, it's better if you go and use the sub. This is representing the separator \t. A tab space will be provided for each and every column. Why? You are storing the results. You are exporting the results to a txt file, text file. So in this way, you can store the results. You can export the results to a CSV file, text file, whatever the file it might be. What if I want to read the data from a CSV file or Excel file? We have already discussed. If you want to read the data from a CSV file, we have a function called read underscore CSV from Pandas. Just specify the path. See, within the read underscore CSV function, you have to specify the path of your CSV file. This is the path of my CSV file. So when you execute the line, what happens is PVM understands that it is the file path and it goes to the location and it reads the data that is present in this CSV file. Okay. So whatever the data that is present in this file gets read and that data will be stored in DF. Let me do it. Done. So let me open the data frame DF. See. So this is my data. This is my data which I have read from a CSV file. And I can also print it using the print function. If I want to have a look, I can print the data to the console. In the same way, can I also read the data from an Excel file? Yes, we can also read the data from an Excel file, guys. But the function will be read underscore Excel. The function will be read underscore Excel. So this read underscore Excel function is also from Pandas. Okay. And the only thing that I have to do is I have to specify the path of the Excel file in which we have the data. So I have took a file, Excel file where I have the data related to some store. Okay. So this is the path of the Excel file. When I execute this line of code, this will read, the PVM reads the data that is present in this store.xlsx file and it stores in the data frame DF. It stores in the data frame DF. Let me open DF. If you see, what is the size of the data frame? 100, 31. 100, 31. So let me open this data frame DF. You'll observe 100 records and 31 columns. There are 31 columns and 100 records, guys. So in this way, you can read any data which is present in any file format. Okay, but you are only supposed to choose the right function from pandas. Read underscore CSV, read underscore Excel. In this way, you're supposed to choose the function. That's it. And finally, I can also print the data that is available in the DF. Done. Okay, so when it comes to pandas, especially we'll be dealing with data frames and series. So all the hands-on is also related to data frames and series. And I hope we had a great session today. And what you are supposed to do is practice. As you are listening for the first time, you have to practice for a number of times so that you'll get habituated. Right? You'll be habituated to the functions, the process, the syntaxes, especially the syntaxes. Memorize the syntaxes. Excuse me. Right? So this marks the end of Pandas. And I hope we had a great session today. Not only a great session, a great program we had so far. And I'll give you enough amount of time, guys. Utilize the time for questions. Any technical questions. Yes, any technical questions? Right. So from the next Monday, it is 4th of August. Okay, from 4th of August, we are going to start a program related to Power BI. Okay, so these sessions will be hardly for 10 days, guys, where you'll be learning the concepts related to Power BI, one of the leading business intelligence tool in the market. Okay, so you'll understand the purpose of Power BI. What is the purpose of it? Why should one learn Power BI? What is the use of learning Power BI? You'll be understanding in the coming sessions. Okay, complete your registration and also do share across your connections. Okay, you'll get the, I hope all of you are part of the groups. So as per the groups, in each and every group, even the channel, we are sharing the Power BI registration link. So complete your registration and also do share across your connections. You can share across your, students, your organization, wherever you are. Okay, share across your connections and ask them to learn one of the intelligence, one of the important BI tool. It is Power BI. Don't miss out the sessions. If you did not register so far, complete your registration, guys. And we'll be sharing the registration link here as well. Okay, so complete your registration. Right. So if you find that the session went well and if you find that the program went well, do hit on the like button, encourage us, and also share across your connections. Ask them to learn Python, where we have covered two important packages, NumPy, Pandas, right? So just start hitting on the like button. And if you have any technical questions, yes, you can use the comment section, post your comments. We'll be reaching out to your queries, your questions, your doubts. Yes, the feedback link has been provided. Please provide your valuable feedback before you leave. Thank you so much, guys, for making this program a big one. Let us also do the same in the upcoming programs as well. Once again, thank you one and all. Have a great day.